Whereas before, you're used to talking about angles and circles and turning around in a circle in terms of degrees, you're going to see in pre-calculus, we're going to take the step to working with radians. A radian, the reason why we do this, a degree is kind of arbitrary. Someone decided there's going to be 360 degrees in one circle. With the radian, however, there's more of a mathematical discovery of where it comes from. You'll see this with an activity that we do in here. And a radian comes from laying on a circle circumference, you lay the radius um, on the circumference, and that's 1 radian. So what we really need to know is that with a circle, we're used to knowing that there's 360 degrees in a circle. And then radians, the number you need to remember, there are 2 pi radians for every circle. So if you keep in mind that 360 degrees is equal to 2 pi, we could also divide by 2 here and say that 180 degrees is equal to pi radians. Okay? So with that in mind, just like if you were going to take, let's say you were going to take 6 inches and you wanted to convert it to feet, you would think, okay, for every 1 foot, there's 12 inches. So feet and inches, they're different measurements. However, 1 foot is equivalent to 12 inches. So if I ever want to convert inches to feet, I could multiply by this 1 over 12 feet per inches. And think about that, 6 inches times 1 foot over 12 inches. The units really do cancel out. If you've had chemistry, you've done stoichiometry, you've done a lot of measurement conversions. So inches divided by inches goes away, and now we really have 6 times 1 feet, that's 6 feet, over 12, and 6/12 could reduce to a half. So 6 inches is a half of a foot, which we know, we're comfortable with inches and feet, we know that's true. I say that just to make the radian degree conversions just a little bit easier. So what we saw in the last slide, pi radians is equal to 180 degrees. So if we ever want to go from degrees to radians, whatever unit you're trying to cancel out, it's going to be the denominator of this equivalence right here. So you'll take your degree amount and you'll multiply by pi over 180. So for example, if I'm going to do this 60 degrees here, 60 degrees times pi over 180 degrees. The degrees really cancel out. 60 divides by 180, I can reduce that and divide both by 60, and I really get 1/3, and then times that pi right there. So 1/3 of pi, likewise, I could just write pi over 3, because 1 times pi is just pi. So, all right, I'll do likewise, going from radians to degrees. All right, same thing, we still use the fact that 180 degrees is equivalent to pi radians, but now since we're trying to cancel radians, pi is our denominator. So let's say we're doing this 2 pi over 9 here. 2 pi over 9 times 180 degrees over pi. All right, if you see anything that can cancel out, use that to your advantage. So a pi over a pi reduces to just 1. We can cancel that out. 180 divides by 9 20 times. So 2 times 20 will give us 40 degrees. One thing you might remember from Algebra 2, finding arc length. So before you've probably done it with degrees. Now we can do the same thing with radians. It's actually a simpler equation here. So S stands for the length of the side. And remember, we call a piece of a circle, which is just a piece of the circumference, so we call that an arc. To find the measurement of that, you can't just lay a ruler on it because it's curved. But one thing you can do, if you know the radius measurement, and you know the angle that corresponds, so here's my circle, there's the center. All right, if this is what I'm trying to find the measurement of, the central angle that corresponds with that arc is what we're talking about with this angle right here. With this, we want that angle to be measured in radians, right? And simply multiplying the radius, the length of the radius, times this angle, we'll find the length of this side. So one example here, we're finding the angle, all right, for a circle. This time they're telling us the arc length, 31 inches, and we know the radius. So we can set up our equation here. 31 is equal to 12 times the angle. We use theta a lot of times to talk about angles, just like we use x a lot of times in algebra for an unknown variable. And all we want to do is get theta by itself, since that represents the angle. We can do that if we divide by 12. So theta equals 31 divided by 12 radians. All right, likewise, number 2 here, find the arc length of a circle with a radius of 9 feet and a central angle of 60 degrees. Got to do a little bit of work because we do want to find our angle in radians. So to convert degrees, 60 degrees times pi over 180. That reduces to pi over 3. So to find our arc length, all we do is take 9 and multiply by pi over 3. 9 divides by 3 3 times, so really this is going to equal 3 pi. So just giving you a little intro to the unit circle. We're going to talk a ton about this year, particularly this semester. When we say unit circle, we mean a circle with a radius of 1. So with that in mind, the circumference of the circle would just be equal to 2 pi. And some things you want to talk about here to really help you with a few questions that we're going to be getting as we start to dive into this topic. The standard position, all right, we know that right here on the initial side we're at 0 degrees. We talked about one quadrant here, we have a right angle, this is 90 degrees. This would be 180 degrees. 180 plus another 90 is 270. 270 plus 90, 360. Okay, so that's great, and that's all true. But we're making the switch into thinking about radians. So if we want to label the circle in terms of radians, this is still going to be 0 radians here. But one full revolution around the circle would equal 2 pi. So 360 is equal to 2 pi, 0 is equal to 0. All right, let's do the easy side over here. If we only went halfway, we'd only go half of 2 pi, which is pi. And if we stopped at the end of one quadrant, we only went halfway to pi, that's going to be half of pi, or pi over 2. So what that tells us, each quadrant is pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. 3 pi over 2. If you instead went and did the conversion and multiplied all of those degrees by pi over 180, you would clean up your answer and get the same thing we just did by thinking about more of a fraction approach to the circle. Alright, so similar to some examples we worked earlier with degrees, now we're going to talk about finding the quadrant the angle that's measured in radians would be in when drawn in center position. It's going to work the same way. It really helps for you to label your 4 corners. That's what I'll call these guys. So, alright. And then it really helps to think about fractions. So I kind of like to see this as 3/4 of pi. When I think of it that way, I know we're more than half a pi, but we're not quite 1 full pi. So that would tell me that 3 pi over 4 would end up right here in quadrant 2. Okay. All right, likewise, this little meter. Okay. 9 pi over 7 here. So notice that is more than a pi. Alright, that's 9/7 of pi. So we would be past pi. And then 3 pi over 2, maybe we could think of a common denominator to help us out with that if we weren't so sure. So something over 2 and something over 7 have a common denominator of 14. I'll put first because we're comparing. So 3 pi over 2, to put that over 14ths, multiplying by 7, is the same thing as 21 pi over 14. And 9 pi over 7, I would multiply by 2, so that would be 18 pi over 14. I see that this is a little less than 21 pi over 14. So 9 pi over 7, bigger than pi, but not quite as big as 3 pi over 2. That's going to be quadrant 3. Alright, and then let's see, 7 pi, this one's going to be pretty easy for us because, think of it this way, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So notice when we're on this x-axis here, we're not really in a quadrant. So that's a trick question. So 7 pi isn't in a quadrant, it's on the x-axis. It would be coterminal with pi. And then 4, that seems a little confusing. Okay, I would recommend now to actually think about what it means to say 2 pi. 2 pi is the same thing as saying 2 times, think about what pi equals, 3.14, goes on for a while. So 2 pi here is really equivalent to 6.28 and some change. So pi here will be 3.14 and some change. So 4 is bigger than pi, not quite to 2 pi. Think about this right here. 3 pi over 2 is the same thing as saying pi plus a half of a pi. So if you had 3.14 and you added a half of a pi, that would be adding like 1.5 basically. So think about this. This would be more than 4.5. So 4 here must be somewhere in quadrant 3. It's not quite as big as pi and a half. Finding two coterminal angles, now we're just going back and doing the same thing we did when we were finding coterminal angles with degrees, adding or subtracting a circle. When we're talking about radians, we're adding or subtracting 2 pi, which is equivalent to 360 degrees. The hardest part here is just working with fractions. So taking number 1 here, 2 pi over 3 plus 2 pi. Well, it would really help if we had a common denominator for this 2 pi. We can do that by putting it over 3. And think about right now, 2 pi was over 1. Changing that denominator to 3, we're really multiplying this fraction by 3 over 3. So that's equivalent to 6 pi over 3. So 2 pi over 3 plus 6 pi over 3, that's the same thing as 8 pi over 3. I could do the same thing and add another 6 pi over 3 to find another coterminal angle. Let's do one more example here, number 2. So negative 7 pi over 6. How about we find a coterminal angle that's more negative? We could do that by subtracting 2 pi. In terms of 6, 2 pi is the same thing as 12 pi over 6. So negative 7 pi minus 12 pi all over 6, that's going to be negative 19 pi over 6. So that's one possible answer for coterminal. Remember that you really have an infinite amount of angles when you're finding coterminal. Complementary and supplementary, they haven't changed meaning. Complementary means you're finding two angles that add to 90 degrees. In terms of radians, that just means two angles that add to pi over 2. And supplementary, two angles that add to 180 degrees. And radians, that means the two angles add to pi radians. Alright, so I'm just going to pick 2 pi over 5 here. Finding the supplement, well, we need to take 2 pi over 5 and find, I'm going to label it theta, plus theta, what angle we'll add to, if we're doing supplement, that's like 180 degrees. That's where our brain goes first. 180 degrees is the same thing as pi radians. So we want to get theta by itself. We can do that if we subtract 2 pi over 5 from pi. So theta equals pi minus 2 pi over 5. Once again, we need a common denominator. So if I want to be able to put pi over 5, we've also got to multiply the numerator by 5. And we find out the supplement of 2 pi over 5 is 3 pi over 5. Alright, so this was supplement. And if we're going to do the complement, we're looking for 2 pi over 5 plus some angle equal to pi over 2. That's the same thing as 90 degrees. And likewise, we can find that if we subtract and say pi over 2 minus 2 pi over 5. And let's see, if we wanted to find a common denominator for 2 and 5, we could turn both fractions into tenths, which means I need to multiply the first fraction by 5 over 5, so 5 pi, and the second fraction by 2. Okay, 5 pi over 10 minus 4 pi over 10, that is pi over 10.